Hello, everyone. My name is Yari Salama. I'm the product manager of Salesforce Platform Data Services, and this is the develop apps with big data scale, with big objects and Async SOQL. And I'm here joined by
Cody Marcel, principal engineer on the Platform Data Services team.
Hi, I'm Jan Fernando. I'm architect on Platform Data Services team.
Excellent. So with that, let's get started. First and foremost, let me give you very quickly the forward-looking statement. We might cover some pilot features here. We do our best to call those out, and then if you make any purchase decisions, make those by readily available features. And now to the land of big data. So thank you so much for your interest on big data. Maintaining big data infrastructure can be very, big taxes on resources and expenses. You might be in a situations where you have a lot of different data sets in Salesforce, AWS, in Google, in your analytics environments, in your marketing environments. Making those integrations, they're rather complicated. There's a lot of thinking when it comes to working with big data. It feels like you're juggling a lot of different projects in the air. We have a product within Big Objects that you already might be somewhat familiar with. If you haven't, go and earn the Trailhead badge. We have a great Trailhead on Big Objects, as well as here in Salesforce Dreamforce. This year we are launching the Big Object Creator. This is a new component in AppExchange that allows you to create big objects with the UI, as well as then provides a custom Lightning list view component to view data on that. We'll be showing a little bit of that in the demo. As well as we have our big object implementation guide and some code and SFDX examples. Please take a picture of the link if you're interested to check out the component. sfdc.co/bigobjectcreator. You can go and download this into your org, and you can then try out big objects, as every org is equipped with big object up to 1 million rows in every Salesforce instance. So big objects really takes on big data in a very simple way. So when you have large data volumes in your org, you can use the tools you're already familiar with, compared to setting up separate third-party infrastructure with separate agreements, build your MapReduce jobs, setting up your Hadoop, HBase, data security, and obviously, of course, building your Salesforce integration with those infrastructures. So it is really a familiar way to manipulate with very large data sets in Salesforce. Some of our use cases are very familiar, maybe if you saw some of the keynotes yesterday. So to really get a full customer 360 view, you might have a lot of data in the current enterprise architecture in AWS buckets or some Oracle DBs that are storing transactional data, maybe some background information of historical data about log data and so forth. So big objects really is a different architecture. It's powered by the Apache HBase architecture, and it scales to a very large volume of data and allows these kinds of new big data applications on the platform. We also work closely with a number of Salesforce-owned businesses like Salesforce Shield, Field Audit Trail, Field History Archive, Big Objects. So a lot of different integrations that happen on the platform, whether they are for auditing, tracking, reporting, as well as then last but not least for historical archive, that you might be a victim of your own success. You have accumulated a lot of data in Salesforce, and you need to keep your operational environment in an effective way, then to offload data into a big data infrastructure, and you can do that all natively in the platform without any performance sacrifice. So we're going to have a really great demos provided by Cody and Jan here from the engineering team. First, Cody is going to talk about, we have this fictional company called Ohana Rentals, at least here in San Francisco in previous months and all around the United States. You might have seen all these electric scooters, bicycles, appear on our city streets. So we have a company here, Ohana Rentals, who are then, in a customer support situation, need to provide information of recent ride history for Lauren. So Cody is going to talk about how to perform real-time queries when you have 500 million rows of data or you have a massive big data situation. And then Jan is going to talk a little bit about Async SOQL, our technology of our compute engine. Let's say you want to build reporting and dashboards and use analytics with our compute. With all that, let me transfer over to Cody, to show you how to work with big objects.
Thank you, Yari, and hello, everyone. So As Yari stated, we have this bike share rental company, and we're in the view of a customer service agent. And you'll see a few dashboards that are very specific here to what a customer service agent might be interested in. And the top chart here shows that we have all-time customer rides at 359 million rows of data in that object. And all of these charts are powered. Initially, the data is sourced from a big object. And you can see one of the differences right away from traditional custom objects is that the scale of this object is at 359 million, which is much larger than you might experience with a normal custom object. However, much of the rest of the object is designed and specifically to look and feel very much the same way as you're used to in Salesforce platform. So as we drill in as a customer service agent, we pretend that maybe a customer might call in about their most recent bike rentals. And we can look at this page and zero in on Lauren Bailey, who's a customer calling in, and we can see this related list. And this related list is a custom related list, and we can see that this data is coming directly out of a big object itself. And you can see how fast this page loaded. Now, we aren't loading 359 million rows of data in this related list. What we're doing is filtering down by the primary key that's a lookup on Lauren Bailey as a contact. And I'll talk about the design, but you can see that the most recent rides show up, which is the relevant data for Lauren at the time. This is synthetic data, so it's a little bit of a little bit old here. But we can see that this is sorted by the most recent rides. You can see the from station and to station for this ride. And this customer service agent can go right in and start talking and engaging with Lauren right away. And if you notice how fast this page loaded, that's doing a query against an object with 359 million rows. If this were a custom object, this page may never load. So that's right away you can see the scale and performance that you're getting from a big object. So let's talk a little bit about design. And we go over to our setup page, and we can look at the big objects that we have in this org. And this ride object here is the big object that's powering that related list. And we can see that it has a prefix ride underscore B. But otherwise, it looks very similar to what you might see in the setup page for a custom object. You have custom fields with various types. One key difference in big objects than you might see in a custom object or any other object within Salesforce is Salesforce has this notion of a 16 or a 15 or 18 character ID, but on a big object, that's a little bit different. The way we identify this object is to what we call a primary key or these indexed fields. And you can see that the first index field is a lookup to the contact. And that's exactly how we were able to zero in right away on, out of those 359 million rows, zero in right on the ones that were relevant for Lauren. And the second part of this row key is the stop time. And we can see that it's sorted descending. And that allows the most recent rides to then surface up. So it's really a top-in query right out of the box on just those two fields. And lastly, we have the trip ID. So if you had that, you could get right to that. So the big objects are surfaced in a way that look very similar through SOQL and whatnot to what you're used to. So you can query them the same way through SOQL as you would any other, with some minor restrictions. And those minor restrictions are that your row key must match your filter criteria so that we don't end up scanning a 500 million rows, and it reacts the same way whether there's one row or a billion rows in that object. That related list is going to load exactly the same speed every single time. So if one of the things you need to think about when you're designing a big object is your row key and its relevance to your primary key and its relevance to the query you want to support. So in this case, we were looking at the most recent rides for Lauren. However, if you were interested in doing lookups by station name, you would want to include that in some degree inside your row key. So you need to include the things that you really want to look at for that very specific purpose in your big object. So there's a bit of a trade-off in the flexibility of the syntax that's supported synchronously. However, if you want to run things against non-row key filters, we do have an option for that, and Jan will talk about that. And I will switch back to the presentation. And hand this over to Jan.
Great. Thank you, Cody. Well, as Cody showed you, that whether you can interact with your big object data through synchronous SOQL just as you can with custom objects and build low latency Lightning UI components. But you have to, in order to do that, as Cody demonstrated, you have to filter and sort by fields that are defined as part of your primary key. But what if you want to query on fields and filter on fields that are not part of your primary key? You want to run an aggregate query, perform joins. Well, that's where Async SOQL comes in. Async SOQL is a technology in the big object ecosystem that's designed to provide you with a way to run batch-oriented, map-reduced style, massively parallel workloads that scan across all the data in your big object, regardless of whether it's 1 billion or 10 billion. What we do at Salesforce underneath the hood is we've built a managed compute engine using the best-of-breed open-source technologies out there, like Apache Hadoop, Apache Pig, Apache Phoenix. And we've provided a simple interface on top of this that allows you, our developers, to express these jobs in the familiar SOQL syntax that you're used to. Now, I'm going to look today at one particular use case where you can leverage the power of Async SOQL. And this is a use case that allows you to extract a subset of data from your big object and push that data into a custom object where you can run reports and dashboards against it. OK, enough of the slides, and let me go over to the demo. So as Cody showed you at the beginning of his demo, for Ohana Rentals, we have this dashboard that we've built that's showing the business user, the sales agent, the current bike rental activity. These charts show things like the top rental routes, top rental routes and top rental locations, top drop-off locations, and so forth. As you can imagine, if we were to try and run the queries that drive these reports across all 359 million, or in a year's time, 1 billion, 2 years' time, 10 billion records, these reports would not be performant. So how do we achieve these reports that allow you to see, like, for example, what's happening in September? What are my top bike rental locations? What are my top routes in September of 2018? This is where Async SOQL comes into the picture. So let me show you how you can build an Async SOQL query to extract this kind of data set. Now, before I dive in, I just want to call out, I'm going to be using Workbench to demonstrate Async SOQL for you, but Async SOQL is available through the Salesforce APIs. So you can code against it programmatically to execute Async SOQL jobs, to poll for status, and so forth. You're not just restricted to using Workbench. But for demo purposes, I'm going to show you in Workbench today. So when you come into Workbench, you'll see under the Queries menu item, as well as the SOQL query, we have an Async SOQL query here. Oh, let me log back in. And here, this first page looks very familiar to how you'd write a regular SOQL query. You go in here and you pick the big object or object that you want to query against. In this case, I'm selecting ride __ B. This is the big object that has all the ride data. And then I'm going to select the fields that I actually want to select out. So I'm going to go through here, and I'm going to select some fields. Start time, stop time, to-station ID, trip ID. And then what I'm going to do here is I want to extract September's data. So I'm going to add a filter criteria where I'm requesting, give me only the rides where the start time is greater than the 1st of September of this year. So I plug that information in, and I add the filter criteria there. Now, if you remember the primary key that Cody showed you, the leading part of the primary key was the contact lookup. But in this case, I'm purely filtering on start time. And that's something that you can do in Async SOQL, because we're going to run this asynchronously. So once you have this defined, you hit Next. And then now you come to this is where Async SOQL starts to become different from regular SOQL. I need to define a target custom object where I'm going to put the results of that query. This defines where the results are going to get written to. So in this case, I'm going to pick a custom object called active_ride _ C. So why am I picking this custom object? Well, let me dive back into our reporting dashboard for a minute and drill into one of the reports in the report builder. As I mentioned, running these reports against the big object itself is not going to scale. But what we do is we're generating this working set in a regular custom object, and we're building these reports and dashboards against that custom object. So here you can see this report that's showing our top routes is using data that's stored in the active rides custom object, which is the custom object that I'm moving the data out of the big object from and into. So going back here now to defining our async SOQL query. I've defined the target object where I'm going to write my data to. And now what I have to do is I have to do some field mapping. On the left-hand side here, I have fields that I selected in my query. And on the right-hand side here, I have fields that are available in my active_ride custom object. So I just need to go through here and do field mappings. Fields have been conveniently named to be very similar. So I'm going through and I'm finding all of these fields: stop time, to-station ID, to-station name, and trip ID. There we go. So I've done all my field mappings. So my final step is I hit submit, and the demo gods have smiled on me, and I have an async SOQL job running right now. So what you see here is a status page that shows you this async SOQL job I've kicked off. It shows you the select SOQL query. It shows you the mappings of the fields and the target object. Additionally, here in Workbench, we have this view status page that will show you all the big objects that async SOQL queries that that are running or you have had run. In this case, you can see that the query that I just kicked off is in the running state. Now, typically, these queries take a few minutes to run, but it'll vary based upon the amount of data that you're trying to scan and also the amount of other workloads going on the compute engine, just like any other asynchronous style process. But this job ID is your handle that you can always look up and see, is my job complete yet? And when it's complete, that data that I extracted now will be available in the custom object, in this case, active_ride _ C. So to wrap up, going back again, what I've tried to show you is that generating these dashboards and these charts, what you can do is you can use async SOQL today to generate these really rich charts and dashboards on big object data by using async SOQL to extract out a working data set, putting it in a custom object, and then running your reports against those. So that's all I have today. Really appreciate seeing so many folks here, and hand you back over to Yari.
Thank you, Jan. What a great demo. As Jan wrapped it as a demo, let me recap here. So you don't need to go to a separate third-party infrastructure to manage your big data on the platform, on the Salesforce platform. You can do it natively with big objects. So you can store, manage massive data sets on the Lightning platform with the tools you learned how to use and love. You can run queries on consistent performance and scale, like Cody showed about synchronous real-time SOQL, and then utilize async SOQL, like Jan mentioned about, against billions and hundreds of millions of rows, and to ensure successful completion of those queries. And also, remember, we talked about the big object creator in AppExchange now available for download. All Salesforce orgs have 1 million rows available out of the box for you to test and try out these big data solutions on the platform. With that, let me just thank you and give you a final heads up on our upcoming Friday talk. We're going to continue our discussion on Ohana rentals and a little bit other use cases as it relates to Community Cloud and other use cases on Big Object. But thank you. The team is going to be staying around in that area right here next to the platform if you want to be sticking around and you have some questions. Thank you for attending, and have a great Dreamforce.
Thank you.